Shout out to Miss Eng for being the best math teacher that there is. And math is easy. Just like 1 + 1 = 2.
Question number 2, given x plus 5. So this is called a factor. It says write the 0 that corresponds to each factor. Write the 0, that means it's going to say x equals. That's what my answer is going to be. So if I set it equal to 0 and subtract 5, I have x equals -5. Your choice is B for number 2. Question number 3, given x equals 2, write the factor that corresponds to each 0. Well, in this case, I want to set it equal to 0. So I'm going to subtract 2 from both sides. My factor is x minus 2. If you'll notice that none of these have x minus 2, your answer is E. 3. Multiple choice factor completely. You'll notice that on your factoring flowchart, you should always ask the question, is there a GCF, greatest common factor? Well, in this problem, there is none. I can count the number of terms, 1, 2. And it's not a difference of squares, because squares goes to the power of 2. So this has to be a sum or difference of cubes. In this case, difference, difference. So I'm going to take the cube root of each of these. Do not include the -1. So that would be 2p. And that would just be 1. 2 times 2 times 2 is 8. P times p times p is p to the third. 1 times 1 times 1 is 1. So this is my A, this is my B. Write out our formula. Notice I've skipped all the math operations. And then I'm going to use my SOAP. Same, opposite of this, always positive. I'm going to go back with my A's and B's. A is 2p, B is 1. Okay, pay attention. A is 2p squared. 2p times 1, and then 1 squared. So this will become 2p minus 1. That becomes 4p squared. And this would be minus minus. This choice, A, your answer. Factor completely, you should always, I loved it because one student actually just wrote this. GCF. Every question that says factor, they just wrote GCF. Good idea, good idea. It does have a GCF. The GCF is, go a little quickly, faster, is 6x cubed. Remember, if you expand them all out, 6x to the 5th, there's 5 x's, 4 x's, 3 x's. You'll notice that they have a 6 and 3 x's as greatest common factor. If you got to this point right here, then I gave you, I think, 3 points only. You got a 2 if you found just a common factor. Here in purple, if you make your X box, A times C is 3, B value is -4, your two numbers are -3, -1, and they go there. So you would have to have this as 4. Question number 8. There are 3 things you needed to do: factor, identify the zeros, and make a sketch. To factor, it has 4 terms, 1, 2, 3, 4. If I use my factoring flowchart, I'm going to do factoring by grouping, which means put it inside the box. So I'm going to put this inside the box. X cubed minus 3x squared minus 4x plus 12. And then I'm just going to pull out the greatest common factor. So this one has an x squared, this one is a -3, and this one's a -4. And this is what I know students were not doing. Everyone say multiply. You can multiply to check your answer. X squared times x is x cubed, minus 3 is -3x squared, x times 4 is 4x, and negative 3 times negative 4 is a positive 12. Alright, once you have the outsides, you have x minus 3, x squared minus 4. Now you'll notice in this problem you have to add a 0x. Now a lot of you guys are misapplying the difference of squares problems. On the previous square, a lot of students got like x squared minus 16 and they thought it was like x plus 16, x minus 16. Again, go through it slow until you understand it. The placeholder there is 0x. This gives you a trinomial a, b, and c. And then you can just do a times c is negative 4, b value is 0, and you'll have 2 and negative 2 as your answer. So 2 and negative 2. And this is x minus 3. They call these linear factorization. They're all to the first power. So that is how do you factor. To solve, you're just going to set it equal to 0. X equals negative 2. Add 2 here. X equals positive 2. Add 3, and then x equals positive 3. And then to graph that, it is a power of 3. So that means it is a odd degree. Starts down, ends up, just like x to the first. I have negative 2, positive 2, and positive 3. There are going to be shoot-throughs on all of those. Y-intercept is 12. Question?
Given x to the fourth minus x squared minus 12, factor completely. So I have a trinomial. 1, 2, 3, that's an a, b, and c. And if I can take half the exponent, let's see if we can take half the leading exponent, x to the fourth, so the fourth, half of 4 is 2. This is good when both these conditions work. You can use x box, so let's do x box. Your a, b, and c, your a value is 1, so a times c, and 1 times negative 12 is going to be negative 12. And then my b value is going to be negative 1. Two numbers that multiply to be negative, or 12 is 4 and 3, and they need to add to be negative 1, so this one is going to be there, negative. Negative 4 times 3 is negative 12. Add those together and you get negative 1. Now let's say you don't know the shortcut. Just take those two values. They will always go there. Remember they're splitting the middle term. So the first term will always go into the top left. The yellow here, negative 4 and 3, are splitting negative 1. So you have to add an x squared. And the last term, minus 12. Just take out your greatest common factor, x squared minus 4, and then plus 3. And then double check by multiplying, and that works. So to factor completely, I have x squared minus 4 and x squared plus 3. But here, if you would recognize, you have to factor that one again. And that's why I drew a kind of a big space right there. If you had put a 0x here, you would have gotten a times c is negative 4, your b value is 0, and your two numbers are 2 and negative 2. So to factor the red, it would be x plus 2, x minus 2. And then this one would just be x squared plus 3. What was the shortcut I was talking about before? Remember, when you're doing this x box method, you only have to do the x when a is equal to 1. If this number is greater than 1, you have to do both x and the box. So to summarize, a is equal to 1, just use the x, and if a is greater than 1, you have to use the x box. But if you forget and don't know that shortcut, you can actually do both and get the same answer. Alright, second step is now find the zeros. How do I find the zeros? Well, these are called factors. I don't know, an obvious way to kind of explain that is they have parentheses. To find or identify the zeros or solve for the zeros, or just solving, I'm going to set each of these equal to 0. And then you just basically solve each one of these. Subtract 2, x equals negative 2. Add 2, x equals 2. Subtract 3, x squared equals negative 3. How do you get rid of the power of 2 there? You have to take the square root. We talked about previously, if you take the square root of an equation, it's plus or minus. And then you have the square root of negative 3. And the factors are negative 1 and 3. Square root of negative 1 is I. So there, this 0 is x equals plus or minus I radical 3. Again, the reason why you have to write that plus or minus is because now if you take one of these, something like I radical 3 squared, I squared is negative 1, and negative 1 that becomes the square root that becomes the I radical 3 squared would just be I radical 3 times I radical 3, which is I squared times 3, which is negative 1 times 3, which is negative 3. So that proves to you, not in the red, but if you put in positive I radical 3 or negative I radical 3, it'll equal negative 3. So there's two answers that you can put in for x. Squared will give you negative 3. Okay.
I'm Mr. Eng's mom. Do your homework.